Okay, good afternoon, everybody. Good afternoon. Thank you very much for coming. We have the Newth Lecture now. Professor Newth, I have some crib sheets here somewhere. Professor Newth was SAM's president in 74 to 79 and was an international authority on experimental embryology. And because of his association with the organisation and his contribution, we have been celebrating the Newth Lecture for, is Anushka here somewhere? Anushka, how many? 17 or 18 years. And every year we invite a distinguished scientist to come and speak to us, and we always associate this lecture with our annual general meeting, which we have just held, annual general meeting of members we've just held. And so here we are. Yes, it's the 28th annual Newth Lecture. It says there, actually. So longer than we thought. There we go. Anyway, it's a great pleasure to introduce Professor Colin Moffat. Colin is, as it says on here, he is the. Does it say on there, Colin? No, it doesn't say on there. Anyway, Colin is head of Marine Science Scotland, and I've known Colin just for a couple of years now, and I have to say we were honoured to have him give the guest lecture at our graduation last year, and a lecture which people are still talking about. It was an outstanding lecture, so I'm sure we're in for a real treat this afternoon. Just a few brief biographical notes about Colin. Colin studied chemistry and did a PhD in heparin biochemistry, so he's a proper scientist. And he did that in Aberdeen. He joined, what was then MAF, the Ministry of Agriculture, Fisheries and Food, which was a very large organisation across the whole of the UK, doing what it says on the tin, really, covering food and fisheries, so agriculture and food and fisheries, at the Torry Research Lab, where he investigated lipid structure and nutrition, so still a real scientist. And then, as one does, if one is competent, he was very rapidly promoted, and he became head of lipids and nutrition at the Food Sciences Lab there. He then moved to the Marine Lab in Aberdeen. When was that?
96.
Okay, so in 96 then moved to the Marine Lab in Aberdeen, which essentially is where he still is, and to Ecotoxicology, and then became head of the environment, dealing with spills and trophic interactions of biological effects. So in 2011, he became head of science for Marine Scotland. Now, during that time, Colin has done some important work for Marine Science Scotland. In 2007 to 2010, there was a very big assessment of the North East Atlantic, the status of the North East Atlantic, and I think that was, I think I'm right in thinking that it really was a model for how to do something like that, and in that sense Scotland was definitely leading the way, and I think the equivalent CFAS in England actually, I think, looked on with a bit of envy as to what was done by Colin and his team. And most recently, he's actually just carrying out, him and his team, a second assessment of that. And Colin tells me that quite a bit of what we're going to hear really actually has its origins in those reports. So Colin, looking forward very much to your lecture. Thank you very much for coming.
Thank you. Well, thank you very much, Nick, for that introduction. I don't think I've ever been called distinguished before, so I'll mark that down as a first. What I'd like to do this afternoon is take you on a wee bit of a journey. Not so much on Scotia. This is my pride and joy, the marine research vessel Scotia. Unfortunately, she's getting a wee bitty old, so I'm trying to persuade my boss to give me a new one. So if you'd like to support me in that, please do. Now, my new boss came from Her Majesty's Revenue and Customs. And he said, how much would this cost, Colin? 25 million? And I said, no, 80. So I'm looking for 80 million pounds. So, it's a Scottish resource. It's not just for me. So, let's all band together. And hopefully I'll have a new Scotia by 2025 as the target date. But I would like to take you on a journey where at the end of the day, we are all undertaking research into marine. We're all, I think, very passionate about our marine environment. And I would like to try and sort of estimate, where have we got to today in 2017? Where are we in terms of understanding the seas, understanding the oceans, and in terms of deciding what we're going to do or how we're going to do it? So that's what I'd like to do. I, like Nick, wondered who this gentleman was, and I discovered that he was into amphibians in quite a big way. This particular one, he published a paper on the cranial neural crest of this thing called an axolotl, or it's got a fancy name up there as well. And he published it in the Journal of Embryology and Experimental Morphology, which is a journal he actually set up. And today that journal still exists. It's called Development. And so it's nice to see that, again, the association of SAMS with this particular aspect of science, your previous president's sort of watery past, if you like, and actually everybody at some stage in their life, I think, has something to do with the marine environment, including this. Now, hopefully, you've all, Sunday afternoon, you've done the dishes, you've cleared the decks, you've sat down, and you've relaxed, and you've watched Blue Planet 2. And some of the photography in it is just amazing. Now, the key thing about this is that Blue Planet 2 attracted 14 million viewers on its first showing. This was actually more than Planet Earth 2, and considerably more than X Factor or Strictly Come Dancing. So Simon Cowell, eat your heart out, because we've beaten him. And, oh, this has been streamed, isn't it? I have to be careful what I say. Why is it that 14 million people sat down to watch the television when we were showing something about marine? And I think that shows the enthusiasm that everybody has for our seas and for our environment. When I was a kid, I grew up in Stonehaven, and I used to disappear from the house. And if my parents ever wanted to find me, I was down at the harbour or at the beach, playing in the rock pools. And I used to spend hours. And one of the things that used to fascinate me was as I walked along in the sand, my footprints were still there. And I got really captivated by the fact, and then they disappeared. And all this sort of stuff happened. And I really enjoyed sort of that part of life in terms of this. So I think we all have and do have an affinity with the coast. And people like visiting the coast. But what does this also mean? This means that for Scotland, general marine tourism is worth 2.4 billion to our economy every year. And specific specialist marine tourism is worth 1.3 billion to the economy every year. So marine tourism, no, this is my system here. We'll just get rid of that. Marine tourism is worth 3.7 billion pounds to our economy. And look at the areas. This is a bit of a heat map. Look at the areas right over SAMS. So you must be doing something right. You're pulling in 3.7 billion pounds to the economy. So well done. With that sort of pool, you can surely afford 80 million for a New Scotia. But, oh, right, okay. Yes. But you can see where the tourism is, the west coast, in the Minches, and then, of course, we've got our dolphin populations, and the University of Aberdeen has the Lighthouse Field Station coming down the coast. It's very coastal and also in here. But that's what it's worth to our economy. And so not only do people like coming to the coast, they like spending in the coast. And that's absolutely fundamental. But why do we think people like coming to the coast? You just have to look at that and you sort of think, whoa, this is pretty phenomenal. Look at the shapes. Look at the animals. Look at this duck I found in Haven the other day. You can have fun at the beach. There's a family. You can do things together. The scenery is continually changing throughout time, throughout the day. You've got things like the puffins that are along the top of the water, which is absolutely fantastic. And you've got the plants as well. So what we see is we've got this huge range of plants and animals. Our sands on the west coast, beaches there, absolutely wildlife, seabirds, you like seagulls, aren't you? And of course the ice cream, always going right all over the Scotland cat. Sailing, tourism, And the music, by the way, was from Blue Planet. So I thought I'd just borrow it from David. You know, we're at one with each other. I wish. Our seas are, in fact, three-dimensional. And we generally see the surface. Now, the surface is fantastic. But at the end of the day, our sea has a volume, globally, of 1.3 quintillion cubic meters. Okay? Who's going to tell me what quintillion is? 10 to the power, have a guess. 15, up a wee bit, eh? 15. Oh, no, not 50. No, sorry, sometimes say 18? 18, yeah. 10 to the 18. So 1.3 times 10 to the 18 cubic meters of water on planet ocean. Because we shouldn't call it planet Earth. 70% of the surface is water, so let's call it planet ocean. And greater than 99% is actually deep sea. So greater than 200 meters in depth, where light doesn't really get to, where the pressures are fairly significant, and where you get this sort of environment. This is off Rosemary Bank, taken from Scotia, and we found a brand new sponge bed that we didn't even know existed 2 years ago. And it's a massive sponge bed, huge sponge bed. So this is a type of thing that we don't normally see. Now, a question, how much gold is in the sea? Anybody like to hazard a guess? You didn't think you were going to just get to sit there and not answer questions. My goodness me. Lots. Lots. Well, actually, anybody know the concentration of gold per litre of seawater? Any inorganic chemists here? I'll give you the answer then. 13 billionths of a gram of gold in each litre of seawater. But think about the quintillion cubic meters. So I did a wee sum, and I came up with 20 million tons of gold in the sea. Now, what's 20 million tons of gold equivalent to? And I thought, well, how can I sort this out? So I went to James Bond as the only person who can tell me. And I developed my own, well, together with James, of course, Fort Knox equivalents. Because, of course, in Goldfinger, he goes and he does stuff in Fort Knox. So actually, this is equivalent to 4,365 Fort Knox equivalents. In other words, each country in the world can have 21 Fort Knoxes if we got all the gold out of the sea. The only problem is if we've got 20 million tons of gold, it won't be worth so much because actually it's abundant then. But that gives you an idea of the size. So from 13 billionth of a gram per litre, if we were able to suck it out, we would have 4,365 Fort Knoxes across the world.
What about the sediment?
Well, I'm only going for the water, I know, yeah. You know, actually, I'm just trying to get a wee bit of this, and I can retire. So that gives you an idea of the size that we're looking at. Who do you think said this? What about all the things that you said we were to gain? This is a quote. Anybody know? What about all the things that you said we were to gain? Do you want a clue? Yeah? Okay, I'll give you a clue. Here we go, here we go, here we go. Michael Jackson in 1995 was speaking about natural capital and ecosystem services, and we didn't know it. Is that not fantastic? Long before any of us thought about it, Michael Jackson was doing it. He was ahead of the game. I think that's fantastic. But what that means is that back then, people were realizing the benefits of the environment to mankind. That actually we don't want to go around saying it's indestructible. We can't just treat it in some way or with disrespect. And at the end of the day, we have a pop star who realized back in 1995 that there was things to be gained providing we looked after it. And so you could say he is the thought piece for natural capital and the thought piece for ecosystem services. So that's where we're at. And I think it's quite interesting to see that this hasn't come from scientists, this has come from the people who are out there going around and just thinking. Now, of course, I've already suggested through tourism that our marine environment is fundamental to us. And indeed, it is critical to not only our economic well-being, but to our social well-being as well. Of course, it delivers for us a long-established fishing industry. And we've not only got that, but we've got all our ports and harbours. We've got our hydrocarbon extraction for energy. We've got renewable energy. I've already mentioned the environment, the clean, the scenic environment means we've got high tourism. And there's possibility from some of the deep seas. Professor Jaspers at the University of Aberdeen looking for new medicines. But what this means is that economically this is absolutely fundamental to us. And one of the Sustainable Development Goals, SDG 14, is called Life Below Water. So again, we're diving down under the surface in terms of where it is we want to go. And we've got the statement, conserve and sustainably use the oceans. Now, I'm not going to ask someone to define sustainably. It's a bit of a buzzword, which I'm getting a bit fed up with. I can understand why, to some extent, people use it, but I think it's an overused word today. Because what we've got to understand is what it actually means. And we've got sustainably and sustainable development in it. So we've got to think about it. But as scientists, you can provide the answers. to what it is we've actually got to do. The politicians provide the words, you provide the answers. But not only that, we've got the OSPAR Commission in the North East Atlantic Environment Strategy. Now, why am I pushing SDG 14 and why am I pushing OSPAR? Why am I not pushing the EU Marine Strategy Framework Directive, Water Framework Directive, Habitats Directive, Birds Directive? In the future, these may not have much to do with us directly. These will. So in every grant application, folks, SDG 14, the HE targets, those are the things actually that are going to be pushing buttons in the future going forward. Because those are the things which are going to drive where we're going. OSPAR will be driving our biodiversity monitoring. We're driving our chemical monitoring, our eutrophication monitoring, our radioactive substances monitoring, our offshore oil and gas monitoring. And therefore, we've got to become familiar with this and make sure we know what we should be doing. Looking a bit more in terms of the economics of our industry, our Atlantic salmon industry, worth £638 million per annum. The biggest food export from the UK. Not from Scotland, from the UK. Food export. The biggest liquid export from the UK is whiskey. So actually, Scotland's got the top liquid and top food. And actually, the whiskey far dwarfs anything else. But at the same time, look at where this is happening in your area. Well, when I say your area, that's a bit unfair because I'm not just saying you only service this area. You service the whole of the Celtic fringe and up to the Arctic, and I'll come back to that in a moment. But also in terms of a sea fish industry, 60 to 70% of the fisheries are in Scottish waters in terms of UK. And we're about to get control of that back. So what should we do? How should we manage our fisheries going forward into the future? And those are questions that are being worked on at the moment, a £563 million industry. And our shellfish industry, 11.7 million, many of the mussels coming from Shetland. But again, servicing coastal communities, servicing communities where there isn't much industry. I don't know if you noticed yesterday there was a review of the UK categorised as urban, green, landscaped type, farming, and natural. And Scotland was given 70% of our ground is still covered, land base is still said to be natural, with 2.3% being urban, as against 6.7% of the UK being urban. We actually in Scotland have a very, very different terrestrial landscape to the rest of the UK. The other thing is go into Google Maps and look at the road structures in Europe and then look at the road structures in Scotland. Quite a distinct difference. So Scotland has some unique characteristics. So if we've got industries that are functioning there, we should be promoting them. But look at how many of them are indeed dependent on our prime coastal environment. This summarizes a few other things in terms of a few industries, again, sea fisheries, aquaculture, processing, oil and gas, marine transport. Provides just about 50,000 jobs a year and has a GVA of £4.25 billion. So these are the sort of figures that we're looking at in terms of economy. And yes, oil and gas contributes hugely to this, but look at marine transport, massive. And look at the processing industry for fish, crustaceans, and mollusks. What does this mean in terms of where we should be doing our science? What science do we have to be supporting? If you've got a £3.4 billion tourist industry, what should we be doing in science to help that industry to develop? If we've got an industry that's in remote communities and maybe isn't bringing in a lot of money but is providing a lifeline for those communities, what science should we be doing? to support that. And these are the sort of things that you all have to be considering in our journey as we go through. Because each of us have an opportunity just now to provide some stewardship of our marine ecosystems. And that's what it's about. Aberdeen Harbour development, £350 million project. And they've built a cycle route that goes nowhere. I cycle to work every morning. And I saw them building the cycle route. And I thought, yes, because actually when they were putting in the consultation for this, I went along to them and said, the only way you're going to do this is if you put a cycle route in. Now, I couldn't influence in that way at all, but they've actually put a cycle route in. So I was really chuffed. And then, they open it, and I'm cycling along, coming home, and it stops. It doesn't go anywhere. Where the next bit of the cycle route starts, there's a field between them. Now, what's the point in that? Because actually, this is now part of the coastal route, and the only way you can get to the next part of the coastal route is to go down this wee track, which takes you along the top of some sea cliffs, which is pretty dangerous, actually, especially if you've got panniers on your bike. So I'm going to have to chat to them again, I think, and see if I can get my cycle route all the way home. But it's a big project, £350 million, one of the biggest infrastructure projects after the Forth Road Bridge to be done in Scotland. The Forth Road Bridge also associated with water. Now, in Scotland, we have a vision, and I should do this and say how many of you can reproduce Scotland's vision of clean, healthy, safe, biologically diverse, marine and coastal environments managed to meet the long-term needs of nature and people. I hope you can all recite that, because tomorrow morning, you're all going to get a postcard saying, what is it? Programme for Government has just reaffirmed this as where we are going in Scotland in terms of our marine systems. Progressive governments have all signed this off. Labour, SNP. And so we have cross-party support for this as our vision. But not only that, the vision started in Scotland. It became a UK vision. It became a European vision. And ultimately, it has become a vision of the North East Atlantic. That's how influential Scotland is in marine. You are in marine because you're part of Scotland's marine science. So all of these, and in European law, we have clean, healthy, safe, biologically diverse European seas. Under the OSPAR Commission, which is a ministerially agreed commission, we have a clean, healthy, safe, biologically diverse North East Atlantic used sustainably. So they've put that word in. Sustainability. Oh, yes, sustainability. But basically, clean, health, and biologically diverse is the strap line for Scottish waters, UK waters, European waters, and the North East Atlantic as a whole. And it all came from Scotland. And that is something we can be proud of. But what challenges does it give you as scientists? The challenge is you have got to define for me clean seas. You've got to define healthy seas. What are biologically diverse oceans? What should they look like? Are we going to go back to 1500s and say that's what it should be? Or are we going to use some other metric? What would a clean sea be to you? And I would encourage you when you go home tonight and you're having your tea, think about what clean seas would be. If you've got kids at home, ask them, what should clean seas be? What would you want or think of as a clean sea? Many people will come up with different answers, but at the end of the day, that's what we're committed to doing. And somehow in science, we have to define this. We have to define healthy. We have to define biologically diverse. And speaking of biologically diverse, Scotland's coasts and seas are amongst the most biologically productive in the world. And that is because of the nutrients and the heat that flows in from the Atlantic, which is sort of like banquet time every day for all the little creatures that are there. And so what we find is that we've got over 8,000 species of plants and animals, and I'm not going to count the viruses and bacteria because that would make it massive, massive, massive. But look at the shapes. Look at this critter here. Imagine if you faced him in sort of while you're diving and you come up against a wolffish. Wouldn't be very good. But from here, this little Carinia, which of course can cause blooms, which can cause problems for our industry, our aquaculture industry, not from toxins, but simply from numbers. Calanus phymarchicus, an absolutely fundamental food for herring larvae. But it's slowly being replaced by Calanus helgolandicus, which appears at a slightly different time of year. And the two now, the herring larvae and the Calanus, are not coming at the same time. So we're getting little starving herring larvae. And we've got this thing, Arctica atlantica, the ocean quahog. Now, in this same interlude, it doth befall that I one snout by name present thee all. And such a wall as I would have, you think, that had in it a crannied hole or chink, through which the lovers, Pyramus and Thisbe, did whisper often, very secretly. This loam, this rough cast, and the stone, the wall it does present. And this, the chink. Why am I speaking about Shakespeare? Correct, well done. This little critter here was probably alive when Shakespeare was writing these words, because they can live up to 500 years old. Is that not phenomenal? So we've got from the smallest to the largest to some of the oldest animals on Earth. And if you get it wrong and dump something on top of this critter, you get rid of 500 years of growth. So we've got to know where they are. We've got to understand our marine ecosystems. Otherwise, we could end up doing something that we don't want to do. Size was something I was speaking about. Now, this is log of nanometers, all right? So I'm going from 3 to the times 10 to the 10 down to 0. And you see that in the marine environment, we cover the whole range, from the 30-meter whale, blue whale, through the 30-centimeter herring, and down to the sort of 6-7 centimeter nephrops, and then the 800 micrometer zooplankton, the 36 micrometer Carinia, and then down to these wonderful Emillanii huxleyi, which we are already seeing changes in its structure because of ocean acidification. And finally, we've got our marine viruses and our marine bacteria. And I'll come back to nanoparticles because they're quite fascinating in relation to televisions. But that's what we have in our marine environment. And that's what we have to protect. That's what we have to look after. That's what we have to understand on a daily basis. But of course, we do things. We want to chuck muck into the environment, and we do. We want to have and enjoy the nutritious food that we get from the marine environment. We want to have harbours and ports that are well operating, and so we dredge them quite regularly. We obviously want to have our aquaculture industry. We want to enjoy the tourism that exists in terms of our marine environment. But we have all these pressures. And there's another one, marine climate. And I'm not just interested in marine climate, I'm interested in marine climate impacts. Because unless we understand the impacts, we can't do anything about it. Because we cannot and will not manage the marine environment. What we will do and can do is manage the human activities associated with the marine environment. And there's a subtle difference between the two. And that's what we've got to do. And this was launched at the recent MASTS conference in Scotland. Do you know that the MASTS annual science meeting is now the biggest gathering of marine scientists in the UK on an annual basis, and it's in Scotland. Now, consequences of all this sort of stuff. Newton has a law. For every action, there's an equal and opposite reaction. Okay? Now, I've got a friend called Ailsa Hall, who's director of the Sea Mammal Research Unit, and Ailsa and I have come up with the Moffat and Hall first law of human action. One day, will it be as famous? I doubt it. But what we're saying is that for every human action or activity, there is a consequence. And we have got to think in that way. Newton has his apples, we have our ducks. Why do I use a yellow duck as a consequence sign? How many of you have heard of the floaties from the Pacific? A lot of you. Good way of measuring currents around the globe. But a disaster if you actually think about what it means. That these yellow ducks can go on one of the most epic journeys in the world. 3, I think, have ended up in the UK so far, from the Pacific. And if they can make it round, then an awful lot of other things can make it round as well. So there you go. You heard it first here. So in years to come, one of you might be doing this lecture in 24 years' time, which would be the 52nd Newth Lecture. And maybe you'll be able to say, I was there when this was first announced. I can only hope. Anyway, what are the other consequences in real life of this? And one of the consequences is, for the first time, the CO2 concentration in the atmosphere stayed above 400 parts per million. And what this means is that every day the sea absorbs 22 million tons of carbon dioxide, which is half the weight of all cars on UK roads. That means there's 44 million tons of cars on UK roads. That's an awful lot of cars. So we've got to think about reducing it. I've actually challenged myself and my wife to only doing 5,000 miles a year in our car. And I've threatened that actually when we reach 5,000 miles, I'm going to take a strategic bit of the engine out so it won't go anywhere. So she's a bit worried in case I do that, because I tend not to say things without actually doing them. If I say I'm going to do it, I'm going to do it. So we're currently running, close. But I managed to avoid going to a petrol station for 7 weeks. I was really chuffed. So there we go. But there's no problem with the oceans absorbing CO2. They've always absorbed CO2. The problem is that they're having to absorb even more CO2. Now, who can tell me what the pH of the seas and oceans is on average? 7? No, up a wee bit. Up a wee bit. 8? Up a wee bit. Nearly 8.2. Okay. Where are we averaging now? 7.7. Up a wee bit. 7.9. But because this is a log scale, that's a 30% difference in hydrogen ion concentration. We are having an impact. And not only are we having an impact in terms of pH, but we are seeing the effect on Emelanii huxleyi. We are seeing the carbonate structures change as a result of that. So, folks, it's walk to work next week. Now, the key thing is we want to achieve a balance, because we can't go wheeing down the all-green route and forget about the fact that there are 7 billion people on the planet, and there'll probably be 9 billion people on the planet by 2050. But we've got to get the balance right. The balance between how we would like our seas to be and the balance of the human activities that we can manage. And also nowadays we have to introduce the social and the cultural aspects. Where's the science in this? The science is absolutely fundamental. First of all, prevailing conditions, fundamental. So get your underwater flyers, gliders, things out there, 24/7, measuring, taking in the data. Get your drones out there, measuring the chlorophyll 24/7. Well, it doesn't work in the dark, but you could try. So we need to understand prevailing conditions. What are the temperatures? Get that Tyree boy working. Temperature, salinity. We need that information because we need at least 20 years of data in the marine systems before you can say anything that's going to be of any statistical relevance, or so Rob Fryer, my statistician, tells me. So we need that data. In terms of the science, how we would like it, we need to understand how ecosystems function. Can you tell me how marine systems function? You're all looking a bit. Okay? Generally, we're not very sure. How big is natural variation? What's the impact of natural variation on your figures? And can you provide me with state indicators that tell me whether my seas are clean, healthy, or biologically diverse? And can you link the state indicators to the pressure indicators? Because I can only manage the human pressures, and I must know how that pressure affects the state. And that's what you've got to provide me with. And that's what I'm trying to do. And also, none of us, no creature in the sea, is subjected to one force. They're subjected to P8, polycyclic aromatic hydrocarbons, polychlorinated biphenyls, changes in temperature, changes in acidity, different infections, different pathogens, different biological flora. We've now got, or come back, our tuna coming up the west coast. What does that mean? Why have they come back? They used to be here, they disappeared, now they've come back. Why? Can you give me an equation, a model, or something that will show me the cumulative impacts of all these activities on whatever creature you're studying? Because that's the challenge I give you. And what scale is it relevant to assess something across? If we're assessing eutrophication, is it appropriate to do it at the Water Framework Directive water body size? Or should we say, well, let's do it at the North Sea size? Some countries would like it done at the scale of the North Sea because then their figure will become 0. But is that appropriate? What scale should we assess killer whale populations at? Those, again, are questions that science can answer. And also we need the socioeconomics. When we come to assess the balance, we have our human activities. You do all the work, gathering all the data, all the status, all the trends data. You give it to government. You give it to the Regional Seas Conventions. They have a look at it. They introduce programs and measures which try to do something which reflect your science. If it's a warning signal, if the pressure is pushing you towards a poor state, then we try to relieve that pressure. If the pressure is pushing you towards a good state, we might take our foot off the gas a wee bit and let it happen slightly slower. Because ultimately we have a vision. But what you've got to tell us is, where does that vision sit? Does that vision sit bang in the middle, green? Does it sit slightly to this side, or does it sit slightly to that side? Is the vision the same for everything? Those are the questions. Now, we've got all this stuff, but I was going to put a big red skewer through it because it's all EU. We're going to have to devise all this ourselves. Now, we're not going to get rid of the EU Marine Strategy Framework Directive. We're going to take it into our own processes. But at the same time, we have to design the schemes. We have an opportunity to design something which works for our waters. You have the opportunity to design something that works for our waters. Get out there, influence. Give them the science. You could always ask for more money as well. But I'm in first for my boat, by the way. Oops. We do have some tools. We're not starting at 0. We're never starting at 0. The first tool, marine protected areas. And they work up to a point for some people. Other people would say they're not what they want. Do you know marine protected areas have caused the only riot outside the Scottish Parliament since its inception? All right? That's how passionate people are, in this case the fishing industry, about all this sort of stuff. But what we have here is we have Nature Conservation, NC, MPA, out in the deep seas to the west of Scotland, protecting these wonderful deep sea sponge aggregations. But of course, when you come closer to home, recently, there was a flame shell bed that had a bit of an accident when a scallop dredger went through it. It wasn't in a marine protected area. It is now. The advantage that happened there was that from identifying the damage to having a temporary order in place was 6 weeks. That's how quick Scottish Government can work. And again, why? Because of the evidence. Because we were able to go down there with televisions, because we sent divers down there from SNH. And we were able to say, this is what we want to deliver: clean, healthy, safe, biologically diverse seas. This is a map of the use of demersal mobile gears, so ground trawling, from 2009 to 2013. So it's taken from VMS, which is Vehicle Monitoring System, and the darker the brown, the more intense the fishing. So we've got a lot of fishing here, a lot of fishing here, a lot of fishing there. Let us overlay in that the oil and gas licensed blocks. And what you see here is there's some overlap. And look at this pipeline running right through the fishing area, and this pipeline here running right through the fishing area. Let us now overlay on top of that the locations of the ocean quahog. And what you see now is areas of overlap. And we're drawing a lot of these maps nowadays, but in order to be able to draw them, we've got to have the information. We've got to have the habitat information. But it is allowing us to make decisions. But are we going to manage in the future to have a life with our seas? And how I'd like to finish is just to go through some of the outcomes of the Intermediate Assessment 2017, which is an assessment of how we're doing in the Northeast Atlantic. Where are we currently in terms of our systems? And this is another bit of homework for you tonight, because this is entirely web-based. You don't need to go and get a book. You just need to get an iPad or a PC or something. So tonight, when you're having your supper with a cup of tea, you sit down with IA 2017, www.ospar.org, and then you look at assessments, IA 2017, bang. It'll keep you engrossed seriously for hours. I think it is phenomenal. I had the honour of leading the process of producing it, so I might think I'm a bit biased. But 15 countries came together to produce this. And we've developed 47 new indicators. Indicators of pressure and indicators of status. And I said to the scientists from across these 15 countries, I want you to be linking pressure with state. And we want to put all this together. And we've also got socioeconomics, climate change, an introduction. And that's a fantastic photo, isn't it? A cracker. You know, I wonder if got the seal waving. But it's not one of mine, I'm afraid. But it's a cracking photograph. So how are we doing? Now, although many of the indicators are specifically for IA 2017, they have a wide applicability across Northeast Atlantic, but more importantly for us, the North Sea and Celtic Sea. And this is a map of where the indicators are. So this is the OSPAR region, which goes from the Arctic, which is why you guys should be continuing your work in the Arctic, because we have a part. In 2 weeks' time, we have the Arctic Forum. The First Minister of Scotland is hosting the Arctic Forum. There's a science session, and I think Mark Innell is going to be speaking at it from SAMS. Scotland wants to be doing more up here, and so we need to get together and be sorting this out. And partly we can do that because we can say we're supporting OSPAR. And so we go from the North Pole right through. So here's an area up here. Why also do we want to be up here? Look at the number of indicators that we were able to provide for that area. 9, 10, 11, 12, 13. come down here to the greater North Sea, and we had 27 for biodiversity, we had 5 for eutrophication, 11 for hazardous substances, 1 for radioactive, and 1 for offshore oil and gas. In other words, we were able to give much more information about region 2 than we were about this region. Similarly, when you go offshore to region 5, we had 7 biodiversity and nothing else. How can we be serious about managing human impacts if we don't have any indicators of any applicability to massive areas of our seas? We've got to be out there getting the data. And this is where your gliders should be 24/7 out there, back and forth and back and forth and back and forth, gathering the data. So that at the end of the day, we understand what's happening out there, because what happens out there affects what happens here, because it's all interconnected. So that's what we should be doing. Anyway, 47 new indicators. Some of them were thematic in terms of our radioactive and our offshore industries. But these ones here, the biodiversity, eutrophication, hazardous substances, are all new. This is what you can go into in terms of pressures from human activities. And let us have a look at marine litter, because marine litter is a fairly major issue. When we've all, probably you're not going to be very amused when I say this, we've all gone to the toilet today, and we've all flushed the toilet. And as a result of that, we have all contributed to stuff going into the marine environment. For those of you who managed to wash your breakfast dishes before you left the house this morning, and you've poured your squeezy liquid down the sink, it's gone out. For those of you who are wearing fleeces at the moment and have a washing machine that doesn't have an appropriate filter on it, you are contributing to the fibers in the marine environment by a highly significant amount. For those of you who use face washes that are not got walnuts in them, but have plastic bits in them instead, you are contributing to the marine environment. My wife gets really upset with me because I've removed all these things from the house. So she's a bit, oh, Colin. But I take her to Stonehaven and buy her ice creams, so she's happy. But they contribute. So we've got beach litter, we've got marine floor litter, and we've got plastic particles in Fulmar stomachs. Let me go back to this for a minute. And let me think about one bit of litter that you might find on the beach. A supermarket trolley. I'm not going to say a company because I'm being screened by the folkies over there. So a supermarket trolley. Look at the size of that trolley in comparison to the size of some of the creatures. Apart from our sort of bottlenose dolphins and our whales, there's not a lot bigger than this. So if this is going around in the sea, there's a problem. And it's a bit cage-like, so if anything gets stuck in it, it could get stuck in it for a long time. In fact, it might never get out of it. So what is the situation with beach litter? This is the area that we were able to assess. Good, because we're up to the Arctic. But look at the area we weren't able to assess. But no problem, there's no beaches out here. So we're okay. That was my excuse anyway. Well, there are around the Azores, but we didn't go there. But this is where we're looking at. And we're looking at the number of litter items per 100 meters of beach stretch. And actually, round about the North Sea and round about the Iberian coast, the Iberian Peninsula and the Celtic seas, it's round about 500, 600 pieces of litter per 100 meters on the beaches that have been assessed. The area where it's different is in the Kattegat-Skagerrak up here, where we've got as high as 5,000 to 6,000 pieces of beach litter per 100 meters. And over time, 5-year period, 2009 to 14, but it's not a particularly long period, there have been no real trends in terms of overall numbers. Specific items have gone up and down. For example, there are less balloons on the beach down in the Iberian Peninsula than there used to be. The number of cigarette butts, which is greater in the Iberian Peninsula than up here, has stayed about the same. But the other thing is, about 90% of what was found was plastic. So what we see here is this is the plastic bit, whether it's Celtic Seas, Bay of Biscay, Arctic waters, Northern North Sea, Southern North Sea, plastic is the problem. And so we've got to think about that. There are a few other differences, but even in the Arctic, it's basically plastic with a wee bit of sort of wood that's in there. But look at here, in the Bay of Biscay and Iberian Peninsula, there's a lot of paper and cardboard for some reason. Don't get it other places. Northern North Sea, we've got a lot of sanitary products which are not found in the Southern North Sea. So there's a difference in behaviours between those living in the Northern North Sea and those living in the Southern North Sea areas. So there's something we can do. If we can have that in the Southern North Sea, we should be able to have it the same in the Northern North Sea. So we can do things to help this position. But ultimately, what we've said is, to date, we are not meeting the OSPAR target. The OSPAR target which says that we should have a substantial reduction in marine litter, and it should not be causing any effects. Now, for some of us, plastic particles in fulmars' tummies are a bit of an issue. This is the area that's been assessed, greatly reduced on our beach litter surveys. But we have a target. And of course, with the beach litter, we didn't have a target. With the fulmars, at least we've got a target. And the long-term target is only 10% of fulmars should have more than 0.1 grams of plastic in their tummy. Even that is pretty repugnant, but at least at that level, they don't starve to death and die. Whereas a lot of them, 58% of beached fulmars have more than 0.1 grams of plastic in their tummy. And a lot of them are now beached because they're dead, because they have so much plastic in their tummy that they cannot eat anything. And therefore they starve to death. And there's only one group on this planet that are responsible for that, and that is us. Because we produce the plastics. And we produce the plastic bits. And remember, big bits in the marine environment become little bits. And these little bits are what these fulmars, they're flying over, they see this nice, bright, glittering stuff in the marine environment, they go down, boop, swallow it, bang. That's it. And then they starve to death. But look at the trend. There isn't one. And this is starting at 2000 to 2014. The only trend we've got is as you go further north, because we've got Faroes, Iceland, and Svalbard, the concentrations do go down, but they never get below the target value. That's where we are today. Are these clean seas? Now, let me go back to this, and let me focus in on the smaller critters. And to do that, these are the smaller critters, and let me put a few things up there of size. This is a nurdle. How many of you have been nurdle hunting? Yeah? Out you go there tomorrow and do a nurdle hunt. Nurdles, about 5 millimeters in size, are the products, the pre-plastic products, and billions of them are being lost into the environment. You can easily find nurdles. This is the plastic stuff in the squidgy stuff that people use as exfoliants. And look at the size. That's 5 millimeters here. Look at the size relative to this. If you're a little acacia and you've got one of these things coming towards you, it's a bit like Indiana Jones where the big stone's rolling down coming towards you. Smack! Okay? It's going to give you a bit of a dunt. Or if it's this size, well, you can eat it. Here's we've got the size of a human hair as an example. But I mentioned quantum dots. Do you know what quantum dots are being used for today? Any of you bought a new television recently? No? If your television is known as Q something something something, it's probably containing quantum dots. They give phenomenal picture quality. But they're made up of metals and metal oxides which manage to get themselves into the nucleus of cells and damage the nucleus of the cells. And if you damage the nucleus, you all know what happens. So, can't see anything on screen, but you get the message about televisions. Okay? We want better and better and better and better and better. But as I want to better, they have consequences. Every human action has a consequence. And we have some decisions to make. Do you want the best, 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 best? Or do you say we're going to stop here? And therefore, perhaps not put these into the marine environment. Microplastics. Look at some of these figures there. From 504 samples, 36.5 whiting, blue whiting, hart, mackerel, haddock contained macro and microplastics. Microplastics less than 5 millimeters in size. 87% of zooplankton from the Western Channel contained microplastics. Coming to the Clyde, 83% of nephrops in the Clyde contained filaments. Filaments are things that come from fleeces. And look at the number in the Clyde, just down the road. Not only that, but microplastics contain 1 million times higher concentrations of PCBs than the surrounding water. And they've shown that there's a direct correlation between PCB concentrations in northern Pacific pelagic seabirds and ingested plastic particles. Continuing with PCBs, these are they. Legacy contaminants, or so we say. World production banned in 2001. However, there was a report, which I'll come back to, which suggests that there is a country that's still synthesizing them. There are 209 different congeners, which give us a wee bit of problem because the toxicity of the different congeners is very, very different. But biological effects are evident. On Saturday, I was sitting down to my toast and porridge, went onto the website of the BBC, and this comes up: a last refuge for Europe's blighted killer whales. An article about PCBs in whales today. Some of the highest concentrations ever have been detected in the killer whales today. Not back then, and we stopped synthesizing them quite a number of years ago, but we're finding higher than ever concentrations. I can tell whale populations apart by their contaminant loading. That's not something I should really be very pleased about. But biomagnification is in no doubt part of the reason little eats bigger, concentrations increase. But when you start looking at a time series, and this is the data from the cetacean stranding schemes from 1990 to 2012, provided by ILSA from the SMRU, straight line. It's not going down. And therefore, even though we're not producing them, we still have a problem. In terms of these states and trends in sediments, what we find here is we've developed what's called ecotoxicological assessment criteria. And I'm pleased to say that not only have we developed these indicators, but we are now able to say at an area basis whether or not concentrations are going down, staying the same, or going up. And in the North Sea, for the first time, published earlier this year, we've been able to show that in the northern North Sea, between the period 1995 and 2015, the concentrations of PCB in sediments has gone down. It's not gone down in the Irish and Scottish west coasts or in the Irish Sea, but it has gone down in the Gulf of Cadiz and the southern North Sea. So we're seeing some changes, but we're not seeing them everywhere. The other thing is that concentrations are generally below that where we'd expect to see biological effects in sediments, but we're seeing it in biota. Just to finish then, where are we in terms of biodiversity? Do we have a healthy and biologically diverse environment? These are the categories that we've used to look at it. When we look at birds, what we find here is, well, it doesn't look a very healthy situation. And actually, it's not. That's the area assessed, again, very much on the west side of the Northeast Atlantic. What we find is that we have got considerable issues with bird populations. When you look at fish, however, we are in a slightly better situation. Because here we have, in the 1980s, fish populations diminished. We took action. We stopped, or at least reduced the amount of fishing. And this is a large fish index, specifically looking at demersal species. It's been turned around, and our projection is we will cross our threshold value in 2022. That's pretty impressive. Because what that actually says is maybe we will understand MSY, maximum sustainable yield, in 2022. And maybe we'll have reached it. So when we do something, we can make differences. But the science that was required to do this cost millions and millions and millions of pounds. And Simon Greenstreet, who works with me in the Marine Laboratory, spent literally 18 months cleaning the ICES database to get something which he could then use. Because you don't get 7-foot herring in the middle of Germany. This database suggested you might. All right? So what are the key messages that we're giving out? Not surprisingly, marine birds are in trouble. I was really surprised I got that through 15 countries, but I did. Marine birds are in trouble. We're also saying that contaminant concentrations are decreasing, but concerns remain. We're getting mixed signals from marine mammals. In some cases, things are doing not too bad. In other cases, there are issues. Marine litter is a problem. Very clear. You know, the ministers get the message. There are significant problems. Fish communities show signs of recovery, but in some areas. These are the sort of key, simple messages that we need to get out. So, in summary, do we have clean, healthy seas used sustainably? This is my assessment. Okay, this is a lion, and it's sort of chilling out. So we're sort of waiting a wee bit. We're going in the right direction, but we're ready to pounce if necessary. Healthy? Nah, still got a bit to go there. Sort of not quite understanding what's happening to it. Used sustainably? Well, yeah, we could have some smarties and think about it for a wee while. But what's my message to governments? The direction of travel is good, but you cannot be complacent. And there is something else, the elephant in the room, which is climate change. We cannot forget that climate change and what it's going to be. So these are the gaps. Time to do the work. Cumulative impacts, we must be dealing with them. But how? Solve that, and you've got grants for the rest of your life. Deep sea, we want to go out there and pick up the nodules from the deep water so that we can have our smartphones. What's that going to do to the environment? Climate change and ocean acidification, some of it might be positive, but some of it might be negative. What about our modelling? We need to have better model. Now, the shelf sea model is good, but we need to take these things forward. So the conclusions are, we're on the right track. We're getting there. We're going along, but there's lots of gaps. Spatial coverage. Data quality. Do you know, in 1914, a person from the Marine Laboratory dropped bottles into the North Sea. We're still getting them back. That's why we're record holders for the longest, oldest message in a bottle. I love it. But when a bottle arrives at the Marine Lab, I take the bottle, I go to this bit of the laboratory, I pull the book out, I open it up at the right page, and I write right next to it where it was, when it was, where it was found. You try doing that today, because everybody's got it on their own PC, their own laptop, their own this, their own that, in a language you can't read. Actually, we've got to seriously think about this. Lack of thresholds and targets. Where should we be aiming at? And also this link of human pressure to affect cumulative integrated assessments. accessing all the data that exists. How many of you have got filing cabinets full of data that have never been published? Are you ever going to manage to publish them? When I look around the audience, we've got all ages. And I'd imagine some of us, older people, have got a lot of information that's never going to be published. Of course, maybe that's what we should all do when we retire. We should just write for the next 10 years, rather than sort of enjoying retirement. Also, can we have one indicator that gives a specific insight to the biota that are subjected to multiple stressors at any one time? Ultimately, sustainable management of marine and coastal ecosystems is about the management of human activities. Given the progress to date, the commitment of everybody, we will succeed in achieving the right balance. I'm absolutely convinced that we can do it. With folk like Nick leading the charge, and the other leaders in marine science coming together in Scotland, influencing the UK, influencing wider Europe, influencing Northeast Atlantic, I genuinely believe that we can continue to have a life with our seas. I didn't do this on my own. I had many people who helped in Marine Scotland, Jens and Martin, Ilsa and Jen Godwin from OSPAR, and a plethora of people from 15 countries across Europe. We had lots of fun doing it. We're just about to embark on QSR 2023. You maybe invite me back in 2024 and I'll tell you about it. Thank you very much.
Colin, thank you very much. Oh, is this on? Yep, is that on? Yeah, okay, Colin, thank you very much indeed. That was outstanding, as I knew it would be. Thank you, indeed, indeed. We've run on quite a bit, so I don't know if there is perhaps just one or two burning questions, if you're prepared to take them. Yeah? Okay. Anybody got any questions? Alan?
Yes. It's interesting.
Alan, use the mic, please.
Okay. You're commenting there on acidity on the oceans, but what about inshore, along the coastal strip, where, for instance, salmon farms put out half a ton of carbon dioxide for every ton of fish they produce, and at times, like in August, a 2,500 ton salmon farm will be putting in 10 tons of carbon dioxide daily from the cages.
Yep.
Is that making a difference? Are you doing any studies?
One of the big challenges we have with studying ocean acidification is we can't just take a pH meter and stuff it in the water and go and it goes there we go, because we're looking for very, very small changes. We're looking at going maybe to 3 or 4 decimal places, and so we have to use total alkalinity and do a calculation. What this means is that there are not many machines around in the world that can do this. In fact, in the Marine Laboratory, we've got machine number 57, made by a German family on their kitchen table. And this is because these machines are fairly highly specialized. Now, what we are doing is we are working across a range of countries, 22 countries from ICES, to develop a common methodology for accurately measuring pH in our seas. And off Stonehaven, I know that's the other side of the country from the west coast, off Stonehaven, we have what is now globally being recognized as one of the best pH time series. And recently, one of my staff was invited to California to present data on this. Once we've got what we see as a very, very clear methodology, we will then roll that out much wider. So I can't tell you the specifics of close into a fish farm. The one thing I would say about coastal environments is because of freshwater input and rain and all the rest of it, all these sort of things, there's a greater fluctuation in the coastal environments than we see at our site 3 kilometers off Stonehaven, because that's deliberately located where we're not getting massive freshwater inflow. So I can't give you an answer just now. What I can tell you is that we're actively working towards delivering that sort of information.
Thank you. Okay. One last question. Hazel. That doesn't matter. Of course.
Okay, I'm not a scientist anymore. I'll just shout again. I spent all afternoon shouting at the council, so here we are. So I suppose my question follows on from that, which is about the precautionary principle.
Yes.
Fish farms, dumping vast amounts of guff into water. You know, a layperson goes, that's probably going to be kind of messy. Do we have to wait till we measure it and then decide to stop it?
That's an interesting question. And I think that what we have to do, and as with any industry that develops, you start off with an idea, you grow it, and sometimes, as I said, there are consequences of what we do. Now, that doesn't mean to say that we cannot work with those who are in that industry to tackle issues which are occurring. And the example I would give you is the offshore oil and gas industry. When they came along in the 1960s and 70s, they were fairly cavalier about what they dumped into the sea. And we saw concentrations of hydrocarbons increasing. They were using fluids in terms of drill cuttings. There was basically diesel. And the consequence of this was the concentration of hydrocarbons, pollutants, went up significantly. Regulation came in, horsepower decision 2002, and we have since measured the concentrations, and they are actually have returned to background. What that shows is that where you recognize an issue, where you do the right science, where you then introduce appropriate legislation, the industry can not only survive, but can make a profit and can continue to contribute to the overall economic wealth of the country. And so I'm always hopeful that any issue where there is an organization or a company or a function that is having an impact on the environment, we need to get the science right, and we need to work with those who are in that industry to get it to a stage where the environment is not being adversely impacted beyond what we think is acceptable. Because let us be very clear, the environment is impacted. The very fact we want to live as we want to live means the environment is impacted. It's just how far along that line are we, as society, prepared to go? And so there's a societal question in there as well. The scientists can provide the evidence, the scientists can provide the advice, but the politicians, at the end of the day, who are there representing society, can decide where they go with it. And so the key thing is that we've got to understand, we've got to examine, and we've got to take appropriate action.
What was the too big to fail?
Well, that's
I can't speak about banks.
that's a question for the bar, I think, which is where we should be heading, I think. So all that remains for me to do is to thank Colin again for an outstanding lecture. Like you, Colin, I was brought up actually by the sea, but on the west coast of Cumberland in Maryport.
Yeah.
And when I was missing, my parents knew exactly where to find me. So like you, I've spent my entire life really in and around the sea, and just loving it. And I'm delighted still to be able to be involved in the sea. And I'm hoping that, all this work that we all do will allow, certainly, I've just got a new grandchild, my grandchildren to have a life with the sea. And I think it's absolutely incumbent on us all to do what we can for that. And I hope you get your 80 million for your ship. We are only looking for 2 million for a new ship for us. So maybe we should just go for the 2 million first, I think, anyway. So, Colin, thank you very much again indeed, and thank you very much for coming and giving us the Newth Lecture. Thank you very much.
Thank you.